Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, number of great partitions. So this problem, at least the thought process behind this problem is somewhat similar to the problem that we have solved yesterday, the third problem of yesterday's bi-weekly contest. So I would encourage you to watch that video as well. So let's just go ahead with the problem. The problem states that we are given an array nums consisting of positive integers and an integer k, right? You need to partition the array into two groups such that each element belongs to exactly one group. So basically you will be dividing this array nums into two groups and every element should belong to either of the group, right? Now after you divide you make the partitions, you divide into left and right partition, you will just find the sum of each partition, sum of left partition, sum of right partition. Now if if both the sum are greater than equals to k, then this partition is a good partition, right? So basically you have several different ways to partition the array, right? Now there, if both left and right partition sum are greater than k, then you will call this partition a good partition, and you need to just count the number of distinct good partitions that you have. So and since the answer can be very large, you just need to return modulus 10 to the power 9 plus 7. Now why they are saying that answer is very large, let's just try to analyze this. So because how many total partition can be there? So there are n elements, right? And you need to divide it into partitions. So how many total partitions would be there? So total partitions would be 2 to the power n. Why 2 to the power n? Every element here has two choices: either they will go to left partition or they will go to right partition, right? So there are two choices for this element, there is two choice for this element, there is two choice for this element, and so on and so forth. So you just multiply 2 n number of times, and hence 2 to the power n is the total number of partitions that you will get, right? And n, like this 2 to the power n will be very huge because n itself, uh, number of elements in the array is 1000. So 2 to the power 1000 will be very huge, right? It will not fit in the 64-bit integer. So that's why they are saying is return it modulus 10 to the power 9 plus 7. Okay, so now that we understand the problem, like, oh, okay, let's just take an example, one more example. So let's say this is a array, and we need to partition it such that the sum of every partition is greater than equals to 4. So these are some of the valid partitions. So you can just, let's just analyze this partition. So every element is part of one of this partition, right? There are four elements here, and each of them is part of one of this partition. Okay, then sum of each partition, 1 plus 2 plus 3, 6, 6 is greater than 4, and then sum of this partition, which is 4, which is greater than equals to 4, right? So this partition is a valid partition or a great partition as per the problem statement. So that's why we will count that in our result. And there are six such partitions, and hence we return 6 as an answer, right? So hope the problem is completely clear. Now I want to focus you on this part, that it contains positive integers only. So the solution would completely change if this statement would not have been there. So I would encourage you to first watch the video and then think about it yourself, that okay, what you would have done if the problem will have uh, negative integers as well. Okay, or how exactly the solution would change, and why the solution will not work, the current solution will not work. So okay, now you have to partition this. Okay, so first statement is each element should belong in exactly one group, right? So if let's say there are some elements, let's say you choose some element that belongs to the left group, right? So the remaining element will belong to the right group, right? So if the sum of elements that belongs to the left group is x, then the sum of elements which belongs to the right group would be s minus x, right? Because s is the total sum. So because every element should belongs to either of left or right group, so if sum of left partition is x, sum of right partition would be s minus x, right? Now how exactly would you uh, solve this? So you can see there is only one variable here, x, right? So why not iterate over this variable and just find out what we need? Okay, so what exactly we mean here? So x denotes the sum of left partition, right? Now what are the possible values of x? Possible values of x could be anywhere between 0 up to s, right? Now what is why, like, it may happen that you will not put anything in the left partition, in that case the sum would be 0. it may happen that you put everything in the left partition, and in that case the sum would be s, right? So whatever the sum of left partition would be, the right partition would be s minus x. So if we just find the number of ways to partition, number of ways in which left partition would have some 0, 1, 2, all the way up to x, we can just sum all the ones up which are starting from k. So we'll just try, okay, we'll start with k, and we'll just sum this particular part, right? So we'll start with k, k plus 1, k plus 2 of the way to s, and just find out, okay, how many partitions are there which have sum equals to k, or k plus 1 or k plus 2, right? So now what you need to find, you need to just find out how many partitions are there. The new problem statement is how many partitions are there such that the sum is equals to sum x, right? So you need to find number of partitions such that the sum is x, right? So let's see what is the choices with the first element. The first element, you can either take it or you will not take it, right? If you take it, if you take it, what will you remain with? You will say, okay, I took one element here, right? So the sum of remaining elements should be x minus 1, right? So basically, let's say just take a concrete example. Let's say you are finding out the sum number of partitions, that sum is 3, right? So if sum is 3, if you take one, like there's two choice with one, either you will take it or you will not take it. If you take one, you'll say find me all the partitions starting from this element such that the sum is 3, right? Sorry, sum is 2. So you already took one from here, and you want 3 as your total sum. So the remaining sum is 2, and hence you will say, okay, find me number of partitions starting from here so the sum is equals to 2. So what what exactly this problem, like, don't you think this problem is exactly equals to the problem that we are solving? So we are solving, find me all the partitions such that the sum is 3. So we can say, okay, find me all the partitions starting from index 0 such that the sum is 3. Now we are saying, find me all the partitions starting with index 1 such that the sum is 2. So exactly same problems, right? So hope you see the recursion here. So there is a recursive formula here. So let's just try to write that recursion. So f of, notice that there are two things. One is the index which we are starting from, and second is the sum that we need to make, right? So there are two choices. Either you will take that particular index, right, or you will not take that index, right? So if you take this index, you will say, okay, I have taken that index, so find me number of partitions starting from I plus 1 such that the sum is s minus ai, right? Ai is the value of array at position I. Otherwise, you will say, okay, I haven't taken the ith position, so find me all the partition, find me number of partition starting from I plus 1 such that the sum is s, right? So these are the two states. Now you can just memorize this recursion, and you will get the solution. The number of partitions such that the sum is x, sum is s, right? So this will be the pseudocode for the similar. Uh, so we have two things, index and sum. Now if index equals to n, we'll just check whether sum is 0 or not. So what is index equals to n mean? It means you have already traversed the entire array and you are at the last position. So if you are at the last position, only thing that you can make is 0. You can't do anything. You can make the sum of 0. So because you can make the sum of sum 0, you'll just see if the sum is 0 or not. If it is 0, you will say, okay, there is one way, otherwise there is no way, right? If sum is less than 0, we'll just return 0, okay? Because we know every element here is positive, right? Now next we'll check the cache. So this one is the memorization part, okay? We'll just skip it. If we'll just see if we have calculated this state previously. If we have, we'll just return it the saved result. Otherwise we'll just find the result, save it, and then return it, right? So what will be the time complexity? Number of operations we are doing here is order 1, right, inside this function. So inside this function we are not doing much. So it will be how many times we are calling this function. So how many distinct parameters are there with which we can call this function. So number of distinct value of index would be n, right? And number of distinct value of sum would be s, right? So total number of distinct parameters of this function would be n into s, where s is the sum of the elements and n is the total number of elements. So this will be the time complexity of this particular algorithm. Now we have to do this for everything starting from k to s, right? So what will be the time complexity, total time complexity? So this we have counted for single x, right? We have to do this for a lot of things. So you might say the time complexity would be n into s, n into s into s, like this you will do s number of times. But that's not the case, because if you think about it, you are just changing the sum here, right? So what you will do, let's say you're counting for k, so you will just call f of 0 comma k, right? Now if you're counting for, let's say, k plus 1, you'll just call f of 0 comma k plus 1, right? And so on and so forth. So basically you are just changing the parameters of f, nothing else, right? And we have already considered that for all possible parameters, the function, like the algorithm, would take order n into s time. So to solve this particular problem, we will require order n into s time. But this will not pass the time complexity. Why? N is up to 1000, so that is great. But s, which is the total sum of the array, is up to 10 to the power 12. So each element is 10 to the power 9, and there are 1000 of them. So sum would be 10 to the power 12. So we can't have s in our time complexity at all, right? So now what to do? So notice that you are stuck, but now here the constraint will help. The constraint says that k is up to 1000, right? So we have calculated, we are trying to calculate this part, and that's where we are getting up to s. But what about if we try to calculate this part, 0 to k? We'll just calculate starting from 0 up to k. Then the complexity would be n into k, right? Instead of s, we will have k, because k would be the largest sum with which we will be calling f, right? So n into k will pass, right? So with this you might get a hint, okay? Instead of finding out how many partitions are there such that the sum of left and the right partition are greater than k, let me try to find out reverse. Let me just say, we know there are total to the power n partitions, right? We'll just subtract the invalid partitions, right? So what are invalid partition? Invalid partitions are the one which either have left has sum of less than k, or has right sum of less than k, right? So basically, let's just draw another set theory circle that we discussed yesterday's problem as well. So we have this sample space. We just say that, okay, these are all the partitions, this contain all the partitions, right? Now among these partitions there will be some partition in which the left in which the would be left partition would be less than k, right? And then there would be some partition in which the right partition uh, is less than k, right? So this is also less than k, but this is the right partitions. Now but there will be some partition which will be common between these two, right? So what you will need to do, you need to just say, okay, I will subtract the number of left partition which are less than k, and then I will subtract number of right partition which are less than k, right? And then I will add back number of partition such that both are less than k, right? Because we have subtracted this part twice. Like in this part as well, we have subtracted this, and this part as well, we have subtracted this. So we just add it back. Now the problem is, calculate how many left partitions are there such that the sum is less than k, how many right partitions are there such that the sum is less than k, and calculate how many partitions are there in which both left and right has sum less than k. So let's just talk about this particular problem first. So find me all the partitions, left partitions such that sum is less than k. So this you can easily find, right? You can just simply we can just iterate from 0 to k, call this particular function, and we will get this part. We'll just sum everything up and we'll get this part, and we'll get this part in order n into k time, as we just discussed, right? So this part is okay. Now find me all the right partition which are less than k. So this is exactly similar to this part. If the value of this is, let's say, p, the value of this part would be also p. Now, why this is the case? I would leave that as an exercise for you. It is just a symmetry condition. You can just think about it. So we got lk, we got rk. Now, only thing that remains is find of everything that has that such that both L and K, or both left and right partition, have some less than K. So now you can try to solve this with this equation as well. You will see that you will require order nk square time, right? But that is not required. Why not is not required? Let's just think about it. So we have this condition, right? So we say that okay, s and s minus x both are greater than equals to k, right? So if both are greater than equals to k, what is the sum? Like if you just sum them up, s is, so you are saying that x is greater than k, greater than equals to k. You are saying s minus x is greater than equals to k, right? So now if you just sum these two up, you will say okay, s is greater than equals to 2k, right? So if s is greater than equals to 2k, will it ever happen that sum of left is less than k and sum of right is also less than k? If both are less than k, it means s is not greater than equals to 2k, right? So if it is not greater than equals to 2k, you will not find even a single partition, right? So basically this will, if there is something here, if there is something here, it means that you will not, there will not be anything here, like there will not be anything outside, so outside would be 0, right? So basically if this condition is there, if s is greater than equals to 2k, if it is not satisfied, you will simply return 0 because there is no possible case at all. And if this condition is satisfied, if this condition is satisfied, then there is no intersection at all, right? So there will be no intersection at all. So how it will look like? It will look something like this. Either you, this is the sample space, and you would, yeah, you will have this as a boundary in which left like everything here, like these two circle will take the entire space, right? And there will nothing which is greater than, like in which both the partition have greater than k. Or it will be the case that okay, uh, there is a circle, and there will be two circles and both of them would be not intersecting at all, right? So either this case will be true, or sorry, either this case will be true or this case will be true, right? So basically this would be 0. So we don't need to find this at all, right? So like if you find a difficulty in understanding, you can just write this in this way as well. So you will say we want x to be less than k and we want s minus x to be less than k, so let's just sum them up. So we want s to be less than 2k, right? But if s is less than 2k, any of these condition would never be satisfied, because if this condition is satisfied, s should always be greater than 2k, right? So that's how you'll say this particular part is will be 0. So now we get lk and rk, and this part is 0. So we just say 2 to the power n minus lk minus rk. That's it, right? So that's what we have done. So this is just the memorization part. They just forget about this. So we just say what is the total sum of the elements. If sum is less than 2k, we return 0, right? Now, otherwise, we will just find the total number of partitions, which is 2 to the power n, right? So this is just 2 to the power n. I subtracted 2 from here to like forget about 0 case, right? So this you can leave as well. Like I'm starting the sum from 1. Like that's how I've solved it during the live contest. I started the sum from 1. So 0, there will be one case where everything is 0, which is the left part. Left part doesn't have anything, or the right part doesn't have anything. So I just like removed 0 case at all, because here it is given that k is greater than equals to 1, right? So I just removed it from in the beginning, but that is completely optional. Now once you find total number of elements, you will just find the left less than k. And how will you find that? You will just iterate from sum equals to 1 to k and just call this function uh, which will give you the number of partitions or number of ways that the sum is equals to the given sum, right? We'll just sum everything up here, and you will get some number of partitions. That is sum of the left partition is less than k. And as we discussed, number of partitions as the right partition also has sum less than k will be exactly equals to this. So that's why we just subtracted this twice from the total, and finally return this as an answer. Okay, so hope this problem is clear. If you have any doubts in this particular solution, please post them in the comment section below. And as mentioned, I would encourage you to think about the case where this condition is not satisfied. Like, there can be negative integers as well, and you will see how everything changes there. Okay, so hope you enjoyed it. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.